Alright, right now, over here we have on problem 2 of Recitation 5, we said, while making a sword, a blacksmith receives an emergency phone call that must remove a sword from a furnace of 1200 while placing it in a cooling bath of water of temperature of 26. Yeah. The sword can be modeled of 2K of steel, so mass of steel, and constant specific heat of 0.59. Okay. And treat having a water constant properties at 300 Kelvin, which is basically room temperature, so it's like 27 degrees Celsius. What is the minimum mass of water that needs to be cooling in the bath? So none of the water vaporizes. Okay. Uh, Before you start your competition, draw a schematic of your system, identify all boundary, analysis. Please do identify any assumptions. Okay, so we would draw our boundary over here. Okay, and here is our boundary. So we know there's heat going in and uh, going from the sword to the water, but it's not crossing the boundary. So we can assume that the system is adiabatic and there is no work. Okay? And since now we can say it's stationary, and since we're not adding any more water, we can say it's a closed system because the mass isn't changing. Okay, so writing our energy balance, so I have delta U, delta KE, plus delta PE equals to Qn minus Qout plus Qn minus Qout plus. Okay, so it's closed, so there's no mass flow, there's no work, and there is no heat transfer, and it's stationary. Okay, so we know that all this equals to 0, and we know that delta U equals to since these are liquids and solids, we're not going to be using CVCP. We're just going to use the constants of the specific, you know. So it's mass times C of water times T2 minus T1 of water plus mass of this water, mass of steel times C of steel of T2 minus T1 of steel. Okay, so we want to find T2. We don't have T2, and we don't have the mass of water, not the C of water. So to find the constant of water, we go to the tables. A3, we see the water section over here, and we look at, so here is the specific heat. So here is at 0 Celsius. But since it's 300 Kelvin and that is almost 20, that is 27 degrees, we can just assume the 25, and here is our value for C of water. Okay, so we have 4.18 and a mass of water of T2 minus 26 degrees Celsius plus 2 kilograms of water, of steel times 0.59 times T2 minus 1200. Okay, and that would just equal to 0. Okay, so in this question, it says none of the water vaporizes. Okay, so we look at the boiling point and it's 100 degrees. Let's say. So we don't want to reach 100 degrees. We just want to go just above. So we could just like a quick margin, we could just say 99.97 because none of it boils yet. So because none of it boils, we can assume this is T2. Okay, so we can just plug 99.97 for T2, and that would just make it so that, let's move this here. So now we just like multiply everything, So 4.18 times 6. So it's 309.2 of mass of water equals to 2 times 0.59 times 99.97 minus 1,200 equals to 1298. And we just divide everything, so it would be 2, and our mass of water would be 4.198, and that is in kilograms. And that is our solution.